a couple of no, yes, two announcements. So one is your TAs and graders are fixed. So we'll have recitation from today, starting at today we have 5:45, right? Recitation. So that recitation will be there. Now, since we missed a lot of recitations in the first 2 weeks or 1.5 weeks of the class, what we'll do is on Monday, instead of having regular classes, we'll have recitation classes. So the graders and TAs will come in and explain the assignment to you. So so we won't have regular classes on Monday, but we'll have recitation. So only for the assignment. That is one announcement. The other announcement is we need to fix a time and date for your midterm. I'm thinking July 18, Tuesday. Right, July 18, Tuesday during class hours. So I'll post an announcement regarding that. Any questions, any problems? So let's continue our discussion on predictive recursive descent parsers. We said that if there is a predictive recursive descent parser for a CFG, context-free grammar, then that is not ambiguous. So predictive, this bit term, we'll call it as recursive descent parser, so RDP. Right? Okay. So what is this? So this means that predictive parsers are efficient top-down parsers. So this is top-down parser. Why is it efficient? It's efficient because it only looks forward. It does not look back. Why do you need to look back? If the grammar is ambiguous. If it is ambiguous, then that means a particular string can be parsed 2-3 different ways, and you don't know which way to choose. So if you don't know which way to choose, you just randomly choose one path, you go forward and you see that no, that was not the way. Right? So then you have to backtrack. So you have to do unget token a lot of times. You have to backtrack and then again follow the next one. So that backtracking is inefficient. So recursive descent parsers or predictive recursive descent parsers, they are efficient because they don't need backtracking. They don't need backtracking. So if a certain CFG has this type of a parser, then that CFG is not ambiguous. So presence of this parser will indicate whether a grammar is ambiguous or not. So we are trying to discuss how can we ensure that there is a predictive recursive descent parser for a grammar. So we said that okay, we need to define two things. First thing is the first function. What is the first function? The first function takes alpha as input. What is alpha? It is a sequence of non-terminals, terminals, and the empty string. So it takes that as input. Now once it takes that as input, what does it return? We say that okay, if for every alpha, we can follow the rule alpha to find out a string. So by following alpha, we can get a set of strings. And it can be infinite set or it can be finite set, does not matter. Let's consider X to be the set of all strings that can be derived from alpha. Right? So we said that let's X be that string. Now go to the set X and analyze every string one by one. So you take the first string. Take the first string and you see which symbol does it start with. Whatever symbol it starts with, take that symbol, put it into another set called Y. You do this for every string that is there in X. Then the set Y is the output of the first set or first function. Right? So that's how we define first. Follow was an easier definition, but you'll see it's much difficult to derive. So the easier definition, or the definition of follow is that follow always takes a non-terminal as input. It does not take alpha as input. It always takes a non-terminal as input. So when it takes a non-terminal as input, what does it output? It outputs whatever can come after that non-terminal. So after you have parsed the non-terminal A, whatever symbol terminal that can come, that is in the set of follow. Follow set can contain the end of file as well. Follow set never contains empty string. First set can contain empty string. First set never contains end of file. Right. So these are certain rules we discussed. We discussed some examples of first set, and after that we try to see how to calculate first set. So we have all these rules. And we said that the first thing that we need to do is whenever we see a context-free grammar, we have first sets for every non-terminal, right? And the initial thing that we need to do is put these first sets, make them empty. Everything is empty. Then we start following these rules, fill up the first sets. We go one by one for all non-terminals. Once we have passed through all non-terminals, we see whether the first sets have changed. If they have changed, you have to do another iteration. You continue doing that until and unless the first sets of all the non-terminals, there is no change. If there is no change, you stop. Right? So we are going through an example, and we went through the first couple of steps of this example. Right? So we went through this. We didn't go to this. We did up to this point. Was it up to this point that we did? Right? Okay. So we did up to this point. Okay. So now we want to calculate first of A. First of A is a non-terminal. Does the first rule apply? What was the first rule? First rule was we have X. X is a terminal. If X is a terminal, then first set of X is X. Does the first rule apply here? Does not, because A is not a terminal. A is a non-terminal, right? Does the second rule apply? What was the second rule? The second rule was if you have the epsilon string, that is the empty string. If you have the empty string, then first set of empty string is a set with the empty string. Does it apply? No. Does not apply. Right. Now, what was the third rule? The third rule was that you have to find a rule of the form A goes to B alpha. Right? Does the third rule apply here? Yes. There is a rule that A goes to B alpha. So first there is A goes to CD, right? That is one rule. So that is, in that case, what is B? B is C and alpha is D, right? So what did that rule say? That rule said that take the first set of B minus the epsilon, whatever is there, put it into the first set of A, right? So in this case, B is C, and we have C comma epsilon as the first set of C. So you take that epsilon, you delete that epsilon, right? So first set of C minus epsilon is C. So you put that C into the first set of A. The first set of A was A initially, so now it becomes A comma C by applying the third rule. Then the third rule can also be applied to the next one. The A goes to small a, capital A, right? Where small a can be B and alpha can be capital A. So if that is the case, we have to add first of small a minus epsilon to the set first of A. What is first of small a? A. You just use the rule 1, right? First of small a is A. So you take A and minus the epsilon. There is no epsilon, so it doesn't matter. And you put the put the element A into first of A again. Now A was already there, so if you put it again, nothing changes, right? So first set of A is still A comma C. Now you go to the fourth rule. What does the fourth rule say? That you have to find a rule that says A goes to B0 B1, right? So B0 B1 to BK. Do we have such a rule? We have A goes to C. C is B0, D is B1. Now initially you put I equals 0. So if you put I equals 0, what does the rule stand? The rule says that from B0 to Bi, every non-terminal should have epsilon in their first set. If I is 0, then only B0 is left, right? So B0 is what? B0 is C. Does the first set of C have epsilon in it?
Yes.
It does. So rule 4 applies, right? Then what does the rule 4 say? The rule 4 says that, okay, look at I plus 1. Take the first set of Bi plus 1. What is Bi plus 1 in this case? When I is 0, Bi plus 1 is D, right? So you take first set of D, take the epsilon out of the first set of D. First set of D was D comma epsilon, right? So take the epsilon out, put it into the first set of A. So now first set of A becomes A comma C comma D, right? Does the rule 4 apply again? Can I have I equals 1? Can I have I equals 1? If I have I equals 1, what will I have to do to apply the rule? You have to have 1 after. You have to have B2. Do we have B2?
No.
We don't have B2. So rule 4 doesn't apply anymore, right? Now rule 4 can also apply to that other rule. Capital A goes to small a capital A. But it doesn't change anything because small a is already there, right? So rule 4 can also be applied to a capital A goes to small a capital A, where B0 becomes small a and B1 becomes capital A, right? But it doesn't change anything because you only keep on adding a, right? So now up till this point, first of A has A comma C comma D. Now let's think whether rule 5 applies or not. What is rule 5? Rule 5 again says, okay, find a rule such that A goes to B0, B1, B2 up to BK, right? We have that rule, A goes to CD, B0 is C, B1 is D. Now it says that all such non-terminals should have epsilon in their first set. Does that apply?
Yes. Yes.
Both C and D have epsilon in their first set. So what does that rule tell us to do? Tells us that, okay, let's take the epsilon, which is the empty string, put it into the first set of A. So you do that. So now what is the first set of A? You have A, C, D, epsilon. All the rules have been applied to all the production rules, right? So now you are done for A. So now first set of A becomes A, C, D, epsilon. Yes.
If C didn't have epsilon, then D wouldn't be able to be added. The only reason was
If C did not have epsilon, you wouldn't be able to apply rule number 4. So then D won't be added.
So in that case, we wouldn't have C and D would only have C.
You will only have A.
So,
You won't have C, you won't have D. You cannot also apply rule 5, so you won't have epsilon. Yes.
Didn't we get C from applying rule 3? No? So won't we still keep the C, but we wouldn't have
Yes,
D?
yes.
Okay.
Oh yeah, yeah. So you'll have A and C.
Okay.
You will not have D and epsilon. He is right. So you will have C. You will have C because you are applying rule 3. You are not really applying 4 and 5. But you will only have A and C. You will not have D and epsilon. Yes, that's good point. Yes.
So just quick clarification. So rule 5 is epsilon is supposed to be in B0.
B0, B1 up to BK.
Okay. There's a typo on slide 21.
21?
Yeah.
What does it say?
For rule 5.
Oh, the B0, right? Yes, yes, yes. There is a typo there. So rule 5, yes, Typo here as well in 25. So if you go to slide 21, here you have to have epsilon in B0 as well, right? So just that epsilon belongs to B0, that part is not there. There is a typo. I'll fix this typo. So all the B0 through Bk should have epsilon in there in order to apply rule 5. Right? So that's the typo. So we have okay. Now let's compute first of B, and let's see whether first of B changes or not. Again, we cannot apply rule 1, we cannot apply rule 2 because these are not non-terminals and itself. Can we apply rule 3? What is rule 3? Capital B alpha, right? So what is capital B? Capital B can be small b and alpha can be the epsilon string, right? So if that is the case, then first of B doesn't really change. You end up adding B again, right? So it doesn't really change. Then you go to the rule 4. Can we apply rule 4? No. Can we apply rule 5? No. So first of B remains B. Let's see first of C. So first of C, rule 1, rule 2 doesn't apply. Rule 3 applies, right? You can have capital B as small c and alpha as capital C. But again, nothing changes because C is already there. Right? So applying rule 3, nothing changes. Can we apply rule 4? Why not? Yes, B0 C is not epsilon. Right? Similarly, we cannot apply rule 5. Now let's take the other rule. C goes to epsilon. If C goes to epsilon, we can definitely apply rule 5, right? And put the epsilon string in C. But then that doesn't lead to any change. So C remains C comma epsilon. Epsilon was already there. Now does first of D change? I don't think so. Right? First of D also doesn't change. So that keeps that is still D comma epsilon. Now let's again. Now do we need to compute any further? Why? First sets change. Which one change? S and A. The other ones remain the same. So let's compute first of S again. We cannot use 1. We cannot use 2. Can we use rule 3?
Yes.
B alpha. Right? What is B? B is A. Alpha is BCD. So what is the rule? The rule is take first set of B, negate epsilon, put it into first set of A. So here B is A, so take first set of A, negate epsilon, so which means ACD, put it into the first set of S. So first set of S already had A, so basically now first set of S will be ACD, right? Can we apply rule 4?
No.
No? Yes?
Yes.
We have such a rule, S goes to ABCD. So B0 is A, B1 is B, B2 is C, B3 is D. Now can we have I equals 0?
Yes.
We can, right? So I equals 0 means B0 becomes A. So B0 has to have epsilon. B0 has epsilon. First of B0 has epsilon. So what is the rule? You take the first of B0. No, you take the first of B1. Sorry. You take the first of B1 minus the epsilon, put it into S. Right? So what is B1? B1 is B. So you take the first of B, which is small b. Right? Take the first of B, small b, negate the epsilon. There is no epsilon, so it doesn't matter. Put it into first of S. So now first of S has A, B, C, D. Right? So we have applied rule 4 once. Can we apply rule 4 again with I equals 1? Why not? Because B1 does not have epsilon. B1 is B and first of B1 is small b. So B1 does not have epsilon. So we cannot apply rule 4. Can we apply rule 5?
No.
We cannot apply rule 5 because for the same reason B1 does not have epsilon. All the B's have to have epsilon. but B1 does not have epsilon, right? So we have exhausted our rules. First of S now becomes, so you apply all these rules. First of A now becomes A, B, C, D. So A, C, D, come on. Yes.
If the production rule and the first for B didn't have epsilon, then how are we able to apply rule 4 to B and the production rule for S?
One time you can apply when I equals 0. When I equals 0, which means from 0 to I, you have to have epsilon in the first sets. So 0 to I means what? 0 to 0. So only B0 have to have epsilon. So B0 has epsilon because the B0 is A. First of B0 has this epsilon. So the rule says that you have to add first of Bi plus 1. So what is I plus 1? I is 0. So I plus 1 becomes B1. And what is B1? B1 is B in this case. So you can add first of B minus epsilon to first of S. That's how you get the small b in S.
But how do you get the C and D? Because
By applying rule 3. Rule 3 was what? A goes to B alpha. So B, it becomes A and BCD is alpha. So you have such a rule. So then what you do is you take the first of B minus epsilon, put it into S. So B here is A. So first of A is A, C, D, comma epsilon. So minus the epsilon, you get A, C, D. So put it there.
I got it.
Right? Any doubts? Any other doubts in this step? You have to take the rules literally. Take the rules literally and just apply blindly. Don't think. Because if you think, then there will be problem. So that is done. So now we have to do first of A again. Will there be any change in first of A?
No.
I don't think so because first of A mostly depends upon C, D, C and D. C and D haven't changed, so first of A will not change. So it remains the same. First of B, does it change? No, this is just one rule. So first of B does not change. First of C, again it won't change because it only depends upon small c and the capital C. So if capital C hasn't changed, it won't change. First of D, same reason, won't change. Right? Okay, so do we need to go again?
Yes.
Yes, because first sets have changed. Now first of S, we have all the terminals in S. So we can skip some steps. And this is dangerous what we are doing, skipping steps. We should literally apply all the rules, but just to save time, we can skip steps because all A, B, C, D's are there. So the only possible thing that could be added is epsilon. Right? So what rule should we test? We should directly go to rule 5. Because rule 5 is the only rule apart from the rule 2 that can allow us to add epsilon into the first set, right? So let's apply rule 5. Do we have such a rule like B0 to BK? Such a production rule, do we have? The first rule, yes, A, B, C, D. So in order to apply rule 5, what should happen is all those non-terminals should have epsilon in them. Does all those non-terminals have epsilon in them? Do they have them? Which one violates? B. So B1, which is the non-terminal B, that violates. So you cannot add epsilon. So first of S remains the same. First of S remains the same, A, C, D, B. Now first of A didn't change in the first place, so we cannot expect it to change again. So first of A remains the same, first of B will also remain the same, C same, D same. Now do we need to go again?
No.
No, because nothing changed. Right? So this becomes the first set. Any doubts on how to compute the first sets of non-terminals? You have to just follow the rules, take them literally, blindly use them.
Can you explain one more time on how,
The entire
where do you
thing.
get small b from on first of that?
Pardon? What?
The fourth column, first of S, A, B, C, D,
Yes.
B. Where did the small b come from? I can't.
Okay, so where did the small b come from, right? So we need to apply the rule 4 to get small b. How do we apply rule 4? So if in order to apply rule 4 once, we have to set I equals 0, right? So if we set I equals 0, now we need to first find a production rule of the form A goes to B0, B1, B2 up to Bk. So you have to ask that question, do we have a production rule like that? We do, right? The first one, S goes to ABCD. So here B0 is A, B1 is B, B2 is C, B3 is D. Now you set I equals 0. If you set I equals 0, then what does the rule say? The rule says that from B0 to Bi, all the first sets of Bi's should have epsilon in them. So if you set I equals 0, then you only have B0 left. So then the condition is that B0 should have epsilon, the first of B0. Now in this case B0 is what? B0 is A. So first of A should have epsilon. And we see that yes, first of A has epsilon. So now the conditions for rule 4 has been satisfied. So what does the rule 4 tell us to do? The rule 4 tells us that you have to take the first set of Bi plus 1. I was 0, so first set of B1. What was B1? B1 was that non-terminal B. So take that first set of B. What does it have? It has small b in it. So you have to remove the epsilon from that first B. It did not have epsilon, so removal will not change it. So you take that set, which means the set with the string B in it, put it into first set of S.
And then you stop right because you don't continue.
You don't continue. Because the moment you have I equals 1, then the rule 4 says that B0 and B1 should both have epsilon in them. B0 has epsilon, B1 does not. So that rule 4 does not apply. Yes.
So 5 doesn't have an I counter, so.
5 doesn't have an I counter. So 5 says that all of the non-terminals should have epsilon in them. So 5 does not apply here because B does not have epsilon in them. Any other doubts? Everybody understands how we compute first set? So in the homework, in the sample homework, I have such a problem. Right? I have given you such a problem. Try to solve that. And I will post the solutions to the sample homework as well. Or did I already post it? Okay, I will post the solutions to the sample homework so that you can match up. Now I will post a new homework so that you get chance to finish it off before your midterm. Your midterm is on the 18th. So before you are doing your midterm, you can at least submit one homework. So I will come up with another homework and I will post it by today or tomorrow later. Right? And you will have time until the beginning of the midterm to submit your homework. So I will post another homework. So that is first set. Now let's do a follow set. Now before we go into the rules of the follow set, let's take an example. Let's take an example and see intuitively what should be there in the follow set. And then we'll define the rules. Right. So let's say, let's define follow set. So follow set where A is a non-terminal returns the set of terminals and end of file. So it can either have a set of terminals or it can have end of file. Right. And that can appear immediately after the non-terminal. So immediately after you have parsed A, what terminal can occur? Either some terminal can occur or the end of file. Right. So let's take an example. So let's see this example. This is not the same as the grammar that we're dealing with. This is, I think, much simpler. So what does follow S have? Now follow S means what? It means that you have parsed the entire program. Right? S is the start symbol. If S is the start symbol, then that means if you are doing follow S, then that means that You have parsed the entire program. If you have parsed the entire program, you should always have the empty string, right? So follow is, oh no, not empty string, sorry, end of file. You should always have the end of file. So follow is should always at least have end of file in it. It can never be an empty set. Follow is will always have at least the end of file characterized. Now it might have something else. You might write two programs, right? You might write two programs in a file. So then follow might have something else as well. But it will definitely have the end of file character. Because at some point it will end. You cannot write an infinitely long program, right? So at some point it will end. So you will definitely have end of file in follow set of this. So that is the intuition. So now what is follow A? What do you think follow A should be? So follow A means once you have parsed A, what comes next?
In file,
Why?
there's nothing after.
So how can you, so you have to ask the question, how can you come to A? You can come to A by using that state, that rule S goes to A, right? So if you do S goes to A, and then when you parse A, there is just one rule that says A goes to small a, right? So that means you went from S, then went to A, and then went to small a. Now if you do that, then you have already parsed S, right? If you go to A, then that means you have already parsed S. That is the end of parsing S. Do you understand that it is the end of parsing S? Because you have just used the rule S goes to A and there is nothing after it. Right? So if that is the case, then A should have the follow string, the end of file string in the follow set of A. Right? Because there is nothing after. The rule says go from A to small a, and once you have parsed small a, there shouldn't be anything else. You are finished parsing S. So follow of A should also have the end of file character. Right? Any doubts on this one? Do you understand the intuition behind it? Why follow A should have end of file? You have a
They
question?
all have in the file.
Pardon?
They all have in the file. The follow.
We'll see whether they all have end of file or not. We'll see. Let's go forward and then we'll see whether they'll all have the end of file. Follow B. What can it have? Follow B.
Little b.
Why will it have little b?
So when you're asked to parse B, you get big B, little b, or little b.
So you have that rule. Capital B goes to big B and then little b. Right? So capital B goes to capital B and small b. Now when you are parsing B, what do you expect? You expect that you will parse B, but then you have to get a small b at the end. So you can parse B, and after B there can be another small b that comes. So whatever capital B can be, you parse it. But there is a rule that says that we can have a small b after capital B as well. Right? So small b has to be added into the follow set of capital B. It will have small b. Can it have something else?
In the file.
It can also have end of file. Why? Because we have the rule capital B goes to small b. Right? We have that rule as well. So once we have that rule, so when we parse capital B goes to small b, how do we arrive at capital B? There are two ways to arrive at capital B. First of all, use that rule capital B goes to capital B small b, or use the rule S goes to capital B. So if we use the rule S goes to capital B and we are finished parsing B, then that means we are finished parsing S. Right? So if you are finished parsing S, then that means we are expecting end of file. So follow of B will have both small b as well as end of file. Right? Follow of B will have both small b as well as end of file. Any doubts on this? Okay. Then let's apply our intuition to C. Right? So C has two rules. Again, C has the similar rule as B. So what do you expect? What should we have in the follow set of C? You should have little c. Capital C also has another rule that says capital C goes to epsilon. Right? The empty string. So what does that mean?
Can start with epsilon.
So, which means you cannot have epsilon in the follow set. So how can you arrive at rule C? You can take the start symbol S and go to C, and then C goes to epsilon. So once you have parsed C, then that means you have already parsed S also. Potential, right? So as you are saying that all these sets will have empty set. Why? Because you have that rule, S goes to A or B or C, which means if you come to a non-terminal A, B or C, there is always a situation where you come to these non-terminals by parsing one of those rules. S goes to C, or S goes to A, or S goes to B. So if you use one of those rules, then that means after parsing C, you have already parsed S. So if you finish parsing S, you have to expect the end of file at the end. So C, the follow set of C will have C as well as end of file. Do you understand this? The intuition behind follow. We haven't discussed the rules yet. Now what I would want you to do is don't follow your intuitions whenever you calculate follow or first set. Follow the rules, because intuitions can be wrong. Rules are not wrong. Right? So what are the rules? So the first step in calculating follow set is you have to calculate first sets. Right? So that is the first step in calculating follow sets. So you calculate the first sets first. Then initialize the follow sets of all non-terminals as empty sets. That is what we did for the first sets as well. So initialize them as empty sets. Then you apply the following rules until the follow sets don't change. Similar as first set. So this is the first set, first rule. If S is the starting symbol of the grammar, then blindly take the end of file, put it into the follow set of S. That is the first step that you do. Then find a rule, production rule, that is of the form B goes to alpha A. Again, alpha is the same thing. It's a sequence of non-terminals, terminals, or the empty string. Right? And capital A is a non-terminal. So you find that rule, right? That if that B goes to alpha A. Now, if that is the rule you have, then you add follow of B to follow of A. Reverse. Follow of B to follow of A. Can you explain why? What is the intuition behind this rule? Why do you add follow of B to follow of A? What is this rule captured? When you parse A, how can you arrive at A? One possible way. What is one possible way that you can arrive at A?
If alpha is epsilon.
You parse epsilon. So you just use that rule. So you know that there is a rule that B goes to alpha A. So if you are parsing A, then one possible way that I arrived at A is by following that rule. B goes to alpha A. So I parse some alpha, which is some string alpha, and then I parse A, right? So if I finish parsing A, then one possible reason or one possible effect, sorry, not reason. If I finish parsing A, one possible effect is that I finished parsing B. Right? Because I can use that rule B goes to alpha A and arrive at A. Right? So one possibility is that I parsed A because I finished parsing B. So whatever is following B will also follow A. Because one possible rule is B goes to alpha A. Do you understand this? Anybody does not understand this? The intuition behind the rule. I'm reiterating. Let's reiterate once. The reason is, if I'm parsing A, then one possible way of getting to parse A is the usage of that rule. Capital B goes to alpha A. Because I am using that rule, I end up parsing A. Right? So if that is the case, then one possible effect of finishing parsing A is finishing parsing B. Do you understand this? One possible effect of finishing the parsing of A is finishing the parsing of B. So whatever follows B should follow A as well. So that's why you take the follow of B, put it into the follow set of A. There's one possibility of follow set of A. Right? It may not be the only possibility, but at least one. So you have to do union of all the possibilities. So in order to do union, you have to first put follow of B to follow of A. So that is the rule 2. Now let's look at rule C. This is very confusing also. So now you have to find out a rule that is of that form. What is that form? It says that okay, B, there is a production rule such that B goes to alpha. Alpha can be empty string, non-terminals, terminal. Then capital A, non-terminal, followed by some other non-terminals, C0, C1, C2, Ck. So K other non-terminals, actually K plus 1 other non-terminals. So you have B goes to alpha, capital A, and then K plus 1 other non-terminals, C0 through Ck. Now it so happens that all C0 through Ck has epsilon in their first sets. You have already, because the first step in computing follow set is calculating first sets, right? So you already know the first sets of all the non-terminals. Now whatever C0 through Ck non-terminals are there, let's say this is the situation that all the first sets of these non-terminals have epsilon in them. Then what the rule says is that you add the follow set of B to follow set of A. Why? What is the intuition behind this rule? Why do you do so?
Kind of same to rule 2.
Kind of same to rule 2, yes. It's kind of same rule 2. Why is it same? Because if there are epsilons in C0 through Ck, then there can be one possible case where you have a rule where all the C0s and Ck's take the epsilon value. If the first set of C0 and Ck have epsilon value, then they can end at epsilon also, right? An epsilon string has the first set of epsilon. So they can possibly, C0 can result in a string that is epsilon. C1 can result in a string that is epsilon. And so can Ck, right? When you parse Ck, Ck can also result in a string that is epsilon. So there can be one possible string or a set of possible strings where you can use that rule. B goes to alpha A C0 through Ck, and while you are parsing C0 through Ck, you always get the epsilon string. That can happen. So everything nullifies. Then if everything nullifies, then rule 3 becomes same as rule 2. So rule 2, then you follow the same intuition as rule 2 and add the follow of B to follow of A. Do you understand this intuition behind the rule 3? Rule 3 is more general than rule 2. So rule 3 says that if you have such a rule and epsilon is there in first set of C0 through Ck, then rule 3 covers the fact that you can have some strings where you can use that rule to parse, but you parse all C0s and Ck's to the epsilon string, to the empty string. If you do that, then what you should do is you should add follow of B to follow of B. So that is the intuition behind the third rule. Everybody understands the intuition? We'll move on. If you have questions, you can ask me later. Then we have rule 4, which is again more generalization of rule 3, which says, let's say you have that similar kind of rule that you had in rule 3. B goes to alpha A C0 through Ck, right? If you have that rule, then blindly take the first set of C0, negate the epsilon from C0, put it into the follow set of it. You don't have to check anything else. Just blindly do that. Why? There's a very simple intuition to this rule. Why do you do that?
Whatever is in C0 immediately follows N.
Yes, exactly. So what if you use that rule? B goes to alpha A, C0 and C2, C3, Ck. So after parsing A, you will parse C0. So whatever C0 will start with will come after A, definitely, right? If you parse C0 after A, then whatever C0 starts with comes after A. So that's why you take the first set of C0 minus the epsilon and put it into the follow of it. That is rule 4. Then you have this last rule, rule 5. Rule 5 is again an extension, a more generalization of rule 4. What does it say? It says that okay, you have same type of rule. B goes to alpha A C0 to Ci plus 1, then to Ck, right? Now you see that there is epsilon in the first set of 0 through I, C0 through Ci. There is epsilon. Then what this rule tells you to do is you add the first set of Ci plus 1 minus the epsilon to the follow set of A. The intuition is very similar to intuition in 4. Whenever you have that rule, A goes to C0 through Ck, after parsing A, you will parse C0, then you will parse C1, then you will parse C2, if you follow that rule. Now what if C0 parses to the empty string? If C0 parses to the empty string, then whatever C1 starts with will come immediately after A, right? If C0 and C1 both parse to the empty string, then whatever C2 starts with will come after it, immediately after it. Similarly, C0, C1, C2, if they all three parse to the empty string, whatever C3 starts with will come after it, right? So that's why you have to vary this I and check which I has or check a continuous streak of 0 to I, which all have epsilon in their first sets. You only stop at such an I where you do not have epsilon in first set of Ci. Then you stop applying that rule, right? So everybody understands these 5 rules? Let's apply. So we will apply to that same the previous um, program previous context-free grammar. We will apply this rule to that as well. So we have already completed the first step, so we don't need to do it again. So, but that is the first step to completing follow steps. Then the second step is you give everything empty, right? Now you have to calculate follow set of S. Does the first rule apply? What was the first rule? If S is the start symbol, put the end of file in follow set of S. It applies. S is the start symbol. So these are the rules. These are the start set. Okay. So follow set of S should have the empty string. For now. Can you apply rule 2 to the first production rule? S goes to ABCD. No?
Everything else is currently empty.
What? Even if it is empty, but can I apply this rule?
Yes. Yeah.
So what is alpha?
C.
Is it C?
A.
Is it A? What is that rule? B goes to A alpha. Oh no, sorry, alpha A.
Oh, ABC.
ABC, right? So if you want to apply that rule, then alpha will be A, B, C, sequence of non-terminals. And what is A? A is D, right? A will be D. So what does that rule say? The rule says that then add follow of B to follow of A. So take the follow. So in this case, what is B? B is S, and what is A? A is D, right? So you take the follow of S, which has the end of file, add it to the follow of D. So you can apply that rule, right? You can apply the rule 2, and the result of applying rule 2 is don't have that. Oh, that's because it is affecting the follow of D. So since we are not really interested in follow of D, so we did not apply it. Okay. So rule 2 will not change follow of S. Rule 2 does not change follow of S. Rule 2 only changes follow of D. So we ignore that. Can we apply rule 3? And will it change the follow of S? Will rule 3 change follow of S?
No.
Why not? No, even if there is epsilon. What does rule 3 result in? Rule 3 results in adding follow of B to follow of A. Right? So what is B? B is S, and no matter what is A, you don't add anything to B. So that means S won't change. Right? So if S does not change for the time being, we ignore the rule 3. Rule 4, will that change S? It does not change S because we are adding to follow of A. In this case, A is not S, B is S, right? So it won't change. And similarly, 5 will also not change anything, right? Because you are adding to follow of A, not to B. So we are done with follow with S, right? We are done with S. Then we have to check follow of A. Now we cannot apply the rule 1. We cannot apply rule 1 because A is not the start symbol. Does rule 2 apply? B goes to alpha A. Let's take the first rule. A goes to CD, right? In that case, do we have a case where B goes to alpha A? What is alpha?
C.
C, and what is A? D, right? But then you do you change anything to A?
No.
So then that rule doesn't apply. Now let's check the next rule. A goes to small a, capital A. Can we apply the rule 2 to that rule? A goes to small a, capital A.
Yes.
What is alpha?
Small.
Small a. What is A?
Yeah.
Big A, right? Capital A. What does it say? Then add follow of B to follow of A. What is follow of B? Is A. B is A here. So add follow of A to follow of A. Doesn't change anything. Empty string, right? So here, by applying rule 2, it doesn't really change anything. Can we apply rule 3? To A goes to CD. Can we somehow apply rule 3? If we apply rule 3 to CD, regardless of whether we can apply that or not, will it change anything to the follow set of A? No. Can we apply that to rule A goes to small a, capital A? We can, right? Will it change anything? No, because capital B is same as capital A. So rule 3, applying rule 3 will not also change anything. Rule 4. Can we apply rule 4? Even if we apply rule 4 to rule A goes to CD, doesn't change anything. Can we apply rule 4 to A goes to small a, capital A? What is alpha? Alpha is small a. What is capital A? Capital A is capital A. Do we have C0, C1, C2, CK? We don't have. So we can't really apply that rule 4. Can we apply rule 5? No. Even if we apply, nothing will happen, right? Now, can we apply rule 5 to the first rule? S goes to A, B, C. So you have to consider rules that change A. So what rules change A? So if A is on the right hand side of a production rule, then there are rules that can potentially change A, right? So if I apply rule 5 to the first production rule, S goes to A, B, C, D. Can I apply rule 5 to the first production rule?
Yes.
Yes. What is alpha? Alpha is epsilon, empty string. What is A? A is A. C0 is B. C1 is C. C2 is D. So what does the rule 5 tell me? Rule 5 tells me that, okay, you fix an I, right? You fix an I. So let's say I equals 0. Now what it tells me that from 0 to I, everybody should have epsilon in their first set. So since I is 0, so we are only left with C0. Does C0 have, C0 is what? C0 is B, right? C0 is B. Does it have epsilon in its first set?
No.
No. So you cannot apply rule 5. Can you apply rule 4?
Yes.
Rule 4 does not have that restriction. You don't do not need to have epsilon. So if you can have that kind of a rule that B goes to alpha A C0 Ck, what you do is blindly take the first set of C0 minus epsilon and into the follow set of A. So now you can apply rule 4 to the first production rule, S goes to ABCD, right? You can apply that. So if you do apply that, then alpha becomes epsilon, capital A is capital A, C0 is B, C1 is C, C2 is D. So what you do, you take the first set of C0 minus epsilon, put it into follow set of A. What is first set of C0? That is first set of B, right? So first set of B has the string B in it. So if it has the string B in it, you put that into the follow set of A. That is the only rule that applies. So after that, once you have applied all the rules to all the possible production rules that has A, then what you do is you are done. You have follow of A as small b. Do you understand how you get follow of A as small b? You have to apply all the rules to all the possible production rules that are A. Yes.
So in 5, since it says that epsilon only has to be in the first of Ci, but not in the first of Ci plus 1, then why doesn't rule 5 also have B?
Okay. Why does not rule 5 also add B to it? So you set I equals 0. You have to first set I equals 0. If you set I equals 0, then what is I plus 1? I plus 1 is I equals 1. So in this case, what is B0? Or C0, sorry, what is C0?
B.
C0 is B, right? Alpha is empty string, capital A is capital A, and C0 is B. Do you agree or no?
Yeah.
Okay. So if you agree C0 is B, then what is C1? C1 is C. So if I have set I equals 0, it means that from 0 to I, all the Ci's should have epsilon in their first set. So if I go from 0 to I is 0, then I can only go from 0 to 0. So B0 or C0, C0 should have epsilon in it. What is C0?
B.
B. So first of B should have epsilon in it. Does it have epsilon? No. So rule 5 does not have.
So it's basically just a case of the follow rule, because it has A. Unlike the first rule, then you're going one character further, and
Come again?
like the similar first rule doesn't have the capital A after alpha.
Oh yes, it does not have.
So you're just going one character ahead.
Yes. Yeah, it's so yeah. Don't confuse with the first set rules, because in the first set rules you do not have that set A in it, because you have only alpha, then B0, B1. I don't know, something else I forgot. Yeah.
So when we initially started the follow-up S and we got to rule 4, wouldn't that be where we would add the small b to follow A then?
No, yes, but we were focusing on follow of S. So follow of S did not change, so that's why we skipped it.
Okay.
But if we apply that same rule to S goes to ABCD, follow of A changes. So that's why we focus on follow. We do that when we are computing follow of A.
Okay.
So we are just going step by step.
Okay.
So that's why you have to apply all the rules to all the production rules where A is there, right? So what are all the production rules? S goes to ABCD, A goes to CD, A goes to small a capital. To all the rules you have to apply, right? You cannot skip the production rules. So all 5 rules of follow set you have to apply to all the production rules where A appears. So that's why we get follow of A as B in this step. Everybody understands? Let's compute follow of B. So if you want to compute follow of B again, so the first rule does not apply because B is not the first. Start set. Does the second rule apply? Second rule is B goes to alpha A. So is there some rule that says B goes to alpha A? And will it change the follow set of B? There is no such rule, right? So rule 2 will not change the follow set of B. Rule 3, can we apply rule 3? Can we apply rule 3? To which production rule can we apply rule 3?
The first one.
The first one. So S goes to A, B, C, D. In this case, what is B? B of the rule? S. What is alpha? Alpha is A. What is capital A?
B.
Capital A is B. C0 is C. C1 is D. Right? So what does this rule say? Couldn't we have applied rule? What was rule 2? Oh, no. So what does this rule say? So you have to set an I. Is that the rule? I think there is a mistake. Oh, that is the. Okay. So yeah. So what does it say? That you have to have epsilon in all the following non-terminals. So C0, C1, you have to have epsilon. So you have to have epsilon in the first set of C as well as D. Do you have it? You have epsilon in both first set of C and D. So what do? You add follow of B to follow of A. So follow of B is what? Follow of S. So what is it? You have the end of file, right? So end of file, you add it to follow of A. What is follow of A? A is B here, right? So to follow of B, you add the end of file. So after applying rule 3, follow of B has the end of file character in it, right? Then you try to apply the rule 4. Does rule 4 apply?
Yes.
Yes. So in this case, what is B?
S.
S. What is alpha?
A.
Capital A is B. C0 is C. C1 is D. So what does the rule say? Blindly take C0, first set of C0, negate epsilon, put it into the follow of A. So which means follow of A is B here. So take C0 which is C. So C comma epsilon, delete epsilon, put C into the follow set of B. So by applying rule 4, you have follow of B is now C comma end of file, right? C comma end of file. That is follow set of B. Can you apply rule 5?
Yes.
Let's say I equals 0. If I equals 0, then what is capital B? Capital B is again capital S. Alpha is capital A. Capital A is capital B. C0 is C. C1 is D. Now again you put I equals 0. If you put I equals 0, then it says that okay, first of C0 should have epsilon in it. Does it have epsilon in it?
Yeah.
It does. So what you do is you add first of C I plus 1 minus epsilon to follow it. So which means that you add D, right? You add D. So you successfully added D in the first iteration. Make it I equals 1. If you make it I equals 1, will it work? Can you apply rule 5? Yes or no? Is it possible to apply rule 5? Why not?
There's no C2.
There is no C2. There is no Ci plus 1. Even if the condition satisfies, you cannot really do anything. So rule 5 is done. Is there any other rule where we can apply, which we can apply to B? Production rule. No such production rule. Well, there is one rule that B goes to small b, but that is just it goes to a terminal, right? So after this, what we have is follow of B is the end of file CD. Yes.
So I noticed that as we were doing it, we were doing the follow B, but we ended up going back to S. Why did that happen?
Going back to S means the production rule.
Yeah.
So in that production rule S, you have B on the right hand side.
Right.
So you have a production rule where there is B.
Okay.
So you have to examine all such production rules wherever there is B. Right. So since S goes to ABCD, there is a production rule where there is B. You have to examine that rule, that production rule. Right. So now follow has the end of file CD. No doubts. Even if you have doubts, we will answer the doubts in next class. But let's go ahead. We want to discuss follow of C. Now follow of C, which rules do you have to consider? Which production rules? There are three. S goes to ABCD, A goes to CD, C goes to small c, capital C. All three rules you have to, or no, another rule is there, C goes to epsilon. All four rules you have to examine, all four production rules. So you have to apply all the follow set rules to all four production rules. Does the first rule apply? No, because it's not a start symbol. Does the second rule apply? B goes to alpha A.
Yes.
Which one? Which one? C goes to CC, right? So in that case, what you do, you add follow of B to follow of A. Here B and A is same as C. So even if you do that, nothing changes, empty set. So rule 2 doesn't really change it. Rule 3, does it apply?
Yes.
Yes. Where? Which rule? Which production rule?
S.
S goes to ABCD. So what is our alpha? AB. Alpha is AB, not just A. Capital A is C and C0 is D. There is no C1. So do we have epsilon in C0? First set of C0? Yes, we do. So then what we do? We add the follow of B to follow of A. So which means follow of S to follow of C. So now C will have what? The end of file. Right? C has the end of file after applying this rule. Then we go to rule 4. Does rule 4 apply?
Yes.
Yes, rule 4 applies. Alpha is AB again, A is C, and C0 is D. Blindly take C0, take the first set of C0, delete epsilon, add it to follow of C. Right? So what you get? Follow of C now has the end of file and D. Right? Does this rule apply to any other rules? A goes to CD. What? The result will be same, fine, but it does apply to that rule as well. The result is same. C goes to C small c. It will apply there as well. Result is same, right? That's it. Now can you apply rule 5?
Yes.
How will you do that? So you have alpha equals AB, capital A as C, and C0 as D. Right? Even if you apply that, doesn't really change anything because you already have D. You have D end of 5. Right? Can you apply rule 5 to A goes to CD? You can. Alpha is empty, B is A, capital A becomes C, and C0 becomes D, but still doesn't change anything because you already have D in the set. Right? So even if you apply rule 5, it doesn't really change anything. So what you have is okay. So I am applying all these rules again. So what you have at the end let's continue from here. Right? We have a little bit more steps. Yes,
I'm sorry, what's the? Did you see a